I've got enough room down here for a quick note on one of the later problems that people seem to have done a pretty good job of getting. The projectile fired from a height h above the level plane at angle alpha with velocity v0 has final velocity v0 squared plus 2g plus 2gh. I guess we're using h here. Okay, what's the kinetic energy? Final kinetic energy is 1/2 m vf squared. Vf squared is just the stuff under the radical sign, and so it's going to be 1/2 m times this plus 1/2 m times this. You can do that in your head. You ought to do it. Pause for a minute, write that out, and see if you get the same thing I do. That's going to be 1/2 m v0 squared plus m g h. Now there's a connection here that, of course, we won't have seen in Chapter 3, but since we've previewed concepts of energy and potential energy and kinetic energy, we recognize this as what? That's the kinetic energy of the projectile when it started. If m is its mass, then 1/2 m v0 squared is its kinetic energy at the beginning, and mgh is the amount of kinetic energy lost, which is the amount of it's the amount of potential energy lost, which is the amount of kinetic energy gained. So this is the initial kinetic energy, and this is it's going to be the change in kinetic energy, which is equal to the negative of the change in potential energy. So we have an energy conservation situation here, and the result that everybody seems to be getting correctly confirms the energy conservation of this situation, that if there's, for an ideal projectile where there's no air resistance, no dissipative loss, no non-conservative forces acting, the kinetic energy at the end is equal to the kinetic energy at the beginning minus the change in gravitational potential energy.